Morning, pre-calc students. Here's another video on graphs of equations. This is for section 1.2. Again, a lot of the stuff you've done in Algebra 2, but we're going to go through it quickly just to make sure we have a good concept of it. So in a linear equation, what is m? M is our slope. What's b? B is the y-intercept. Not sure why it changed colors on us. Red so it looks different. Okay. Let's see. We got a parabola, quadratic equation. Curve opens up when A is positive. Curve opens down when A is negative. X value of the vertex. That should be, looks like that. That's an R. Is at x equals negative b over 2a. So that's how you would find it algebraically. You could use a calculator to find it as well. We'll practice that later, doing that as well on our calculator. Okay. H comma k equals the vertex. And A equals the vertical stretch or compression. Makes it tall and skinny or short and fat. Okay? All right. Let's keep going. We got circles. R is the radius of the circle. I'll have to jump ahead, but R is the radius, and H comma K is the center of our circle. For x-intercepts, you plug in 0 for y to find it. For y-intercept, you plug in 0 in for x. Okay. Types of symmetry. There's 3 different kinds of symmetry. So when you reflect over if you change the y and make it negative, you're reflecting over the x-axis. Reflecting it up and down, you're reflecting it over the x-axis. So it's x-axis symmetry. When you change the x value and make it negative, you're flipping it left and right, but you're really reflecting it over the y-axis. And then if you change both of them, you are symmetric or reflecting over the origin. So just some definition type stuff to review, make sure we have a good understanding of that. Determine whether the following points lie in the line. We're just going to plug it in, see if it works. Or we could also graph it and take a look at it that way, but algebraically we'll just do it this way. So does 13 equal 10 times 2 minus 7? And I think it does. So it does. So it's a yes. Over here, does a negative 3 equal 10 times negative 1 minus 7? And I don't think it does. So that's a no. That is a big no. Find the vertex of our parabola. So again, we could use our calculator. We'll practice that at a later time, but to do it this way, we'll do negative b over 2a. That's the x equals. So we're going to have negative 8 over 2 times 2. This 2 is here, this 8 is here. So it's negative 8 over 4, which turns into negative 2. So that's the x-coordinate of the vertex. We have to plug in to find the y. So y equals 2 times 2 squared plus 8 times 2 minus 3. So from here, this is 2 squared is 4, so that's 8 plus 16 minus 3. So what does that turn out to be? So this is 24 minus 3 is 21. So our coordinate of our vertex is -2, 21. Okay. We can do the same thing in letter B, but one thing I want you to think about is what does that look like? And maybe we could do letter C first, and that would help us. So we could use our formula again here, but just to think outside the box a little bit, when you graph this, if you know what a parabola looks like, transformation-wise, if you graph it real quick, a rough sketch, a parabola normally looks like this. So that's normally what a parabola looks like. So what happens to the graph when you do a -2 on the outside? We will learn this later, but it moves it down too. So the rough sketch, this is what my graph looks like. Okay, I can erase my other graph. That's a rough sketch. So if I'm finding the vertex here is 0, -2. That's just knowing that trick. The other way to do it is there is no b, so if you plug in 0 for b, so it's -0 over 2 times 1, well, that's going to be 0. And then you plug in 0 for x, and you find it that way. Some different ways. Again, I know I hopped ahead to graph this here. I'm actually going to erase that now so we can plot some points on our graph. But it's just an idea of how some transformations work. So if I plug in 0, I already said I get -2. So what else do we want to plug in? Normally we plug in numbers to the left of our vertex and then numbers to the right of our vertex. So if you plug in -1, -1 squared is 1, -2 is -1. Same thing if you plug in 1, you're going to get -1 as well. It is symmetric over. So plug in -2, you get 4 -2, 2, right? -2 squared is 4, -2 is 2. Plug in 2, get 4, -2 is 2 as well. So then over here on our graph, we can plot 0, -2, 1, -1, -1, 1, and then 2, 2, and -2, 2. So the best that I can do there for that graph is that. So there's my graph. Okay, find the x and y intercepts for each of these problems. So the x int, y int. So how do I find the x int, the x-intercept? Plug in 0 for y and resolve. So it's 0 equals x plus 4, so the x-intercept is -4, again, comma 0. The y-intercept, we're going to plug in 0 for x, so it's 0, comma something. So if you plug in 0 for x here, what happens? Well, you got to solve. So it's y squared equals 4 square root. What's our answer? 2? Close. Plus or minus 2. So we actually have two y-intercepts here. We have 0, comma 2 and 0, comma -2. Actually, two y-intercepts. It's a sideways parabola if you want to think of it that way. That's why there's two y-intercepts. Okay. So x-intercept, y-intercept. If you want to pause, you can try it on your own. Go ahead and do that. Okay. Hopefully you paused and found some answers. Let's check and see how you did. So for the x-intercept, you're going to plug in 0 for y. So that looks like it could be a little more problematic. So I got to solve this. Do we remember how to solve that? Well, we try to factor. Does it have a GCF? Yes. Pull it out. Does that factor further? Yes. The difference of squares. So it's x plus 2, x minus 2. So our x-intercepts are 0, comma 0, 0, I'm sorry, yep, 0, comma 0, and then 2, 2 comma 0. Almost wrote it as a y-intercept. And negative 2 comma 0. So we have 3 x-intercepts here. Y-intercept, plug in 0 for x. That's a lot easier. 0, 0. So these 2 points are the same. It's 1 point. All right? So there's your x and your y-intercepts. Line of symmetry. Line of symmetry. The best way to do this is to graph them and then try to visually see what is going on. Okay? So let's go ahead and do that. Okay, so I'm back with my calculator here. Got it pulled up. So we're going to type in x squared minus 2. And then we're going to graph it. So which way is it symmetrical? Up and down, right? So that is symmetrical over what? That's symmetrical over the y-axis. So on my paper, I would write symmetric over the y-axis. Okay? Pull up your notes. Find the line of symmetry. So that's symmetric over the y-axis. So you could say y-axis. Almost looks like an x. Or what is that line? That line is x equals 0. All right. So now we need to graph the next one. So it's x cubed minus 4x. Graph. Ooh. So I can't really fold it over. It's not symmetric this way. It's not symmetric this way. So it might not be symmetrical at all. Or if you think about it, if you drew a line this way, and I'm actually going to graph it, the line, it is symmetric. You might not know it, but it's symmetric over the line y equals x. So draw that line. If you fold it over this line here, fold this over, it would come down here. And if you fold this over, it would go over. It's symmetric about the origin, really is what it is. So you can see how it would be symmetric there. This is really symmetric over the origin. Okay? So I come back over to my paper and I can write that down. Find the line of symmetry. This is really over the origin, or y equals x. And then I got my last equation to graph. Now if you notice, we can't type it in as y squared. We have to type it in as 2 separate equations. It's actually a square root. It's the square root of x plus 4. If you solve for y, maybe I'm getting ahead of myself. You have to solve for y, and remember that you get the plus or minus. Anytime you take a square root of a variable, you get plus or minus. So there, I have to type it in as 2 separate equations. So then I graph it, and it looks like that. So treat the blue and the red as one equation, one graph. Where is it symmetric over? It's symmetric over this. Well, that's symmetric over the x-axis. So it's symmetric over the x-axis. And what is that line? The x-axis is actually y equals 0. Okay, so that's the line of symmetry. You're finding the line that it's symmetric over. Okay, now we need to graph this. It's an absolute value. Absolute values always look like V's. So the parent graph, or the standardized graph of an absolute value looks like this. If I plot points, I can adjust it or I can find it without adjusting anything or knowing the parent graph. However, I need to know that it's shifted. You got this -1 here. It shifts it. So it actually shifts it to the right one. So my vertex is here, and it goes like a V. So it goes through 1, goes through points like that.